If you take a look, the x values are going up by 2 each time. So if I go up by 2 here, it would put me at 6. The y values are going up by 7. So if I go up by 7 here, it's going to put me at 21, which is why 621 is the correct number. Question number 2. It says, which line has a slope of 1/2? In other words, the slope should be positive. That eliminates 2 possible lines because line A and line B are forcing me in a negative direction. It says, and a negative y-intercept. So where it's crossing the y-axis has to be negative. This is negative, but this one is positive, so it eliminates C. It meant that D was the correct answer. Are there questions on 1 and 2? Number 3 and 4. To me, the nice thing about learning about slope-intercept form is that we learn that slope is how much something is going to change. It's a rate of change. And we learn that B is that initial point, that starting point where it's crossing the y-axis. So if I read this word problem, it says, on a 2-week job, a repairman works a total of 70 hours. Realistically, that's just an X value. It's nothing. It says he charges $75. Is he charging that one time or is he charging it all the time? One time. He charges $75 and what? Notice this says per hour. That makes this the rate of change. It's a rate. And that makes this that one-time fee, the starting point. So which number is the slope? Well, the slope is $40 per hour. And which one's the y-intercept? 75. It's that initial starting point. How much it costs, whether he's there for 15 minutes or whether he's there for 100 hours, he's going to charge you that $75 up front. Are there questions on 3 or 4? Five and 6. Which statement cannot be true of a proportional relationship? Well, to be proportional, it has to be a line, and it has to go through the origin. And it says which of these can't be true if it's proportional? It says it's a line. Well, that can be true. It includes the origin. That can be true. It shows a constant ratio. In other words, K is y over x. It's constant, that constant of proportionality. That's also true. It says it's not linear. Well, it can't be non-linear to be proportional. If it's non-linear, it's curved. Anything curved proportional? No. Number 6, which equation shows a proportional relationship? It would have to be able to be written in this form, and the only one written in that form is C. These two are non-proportional. They're written in the form y equals mx plus b. This, instead of multiplying by x, I'm dividing by x, so it's not in the right format. Everybody good with 5 and 6? Number 7. These two lines are graphs of non-proportional relationships. What makes them non-proportional? They don't go through the origin. The correct answer for 7 is C. Neither one goes through the origin. Number 8, the correct answer is A. And if you think about it, when it says 3.4 million, this is the 3 million. This would be the 0.4 million if I wrote it out. And remember that in front of the decimal, the number has to be between 1 and 9. That would eliminate these two as even being possible. And then I count decimal places. There's 3. There's 3 more, so it should be times 10 to the 6th power. Questions on 7 or 8? Number 9. When they gave me these values, in all fairness, if I'm reading this problem, I probably would write out the equation. It says that it's a $40 setup fee. Is that once? Or is that each time they make a shirt? It's one time. It's a setup fee. What are they charging per shirt? That's the slope. There's the equation. And this really represents x, and this represents y. So, if I replace x with 1, I'd have 12 times 1 plus 40, which is 52. If I replace x with 5, I'd have 12 times 5, which is 60, plus 40, which is 100. If I replaced it with 10, it'd be 120 plus 40, which is 160. If I replaced it with 50, instead of being 100 like this, it's going to actually be 640. Number 10 may be one of the most difficult ones that are on here. Because, bless you, in order to see the slope and the y-intercept, what form would I want it in? What form? I want it in slope-intercept form, y equals mx plus b. Is that in that format? No. To put it in that format, what variable has to be completely by itself? Y. Well, I can put that in that form. If I'm trying to get y by itself, the first thing I'd have to do is get rid of this x. How would I get rid of it? I'd subtract it. It's being added. I've got to subtract it. I can't put x's and 6's together, so it's a negative x minus 6. Is y completely by itself yet? No. What's in front of it? And it's attached by what operation? Multiplication. And how do I get rid of multiplication? If I divide one thing by 2, I have to divide all the things by 2. This cancels out. Although this said a negative x, what's the value in front of x? It's implied. Negative 1. So this is a negative 1/2 x. And negative 6 divided by a positive 2 would make a negative 3. Now it's in this form. And it's easy to identify what m is. What's m? Negative 1/2. What's b? What kind of 3? Negative 3. But you see it? Number 11. The slope can be found by using the slope formula, y2 minus y1 over x2 minus x1. The y-intercept is any time you see where x has a value of 0. Well, if I'm looking at these 2 points, this one, x has a value of 0, so the y-intercept is a, no, the y-intercept is what? -1. The slope would be y2 minus y1. -1 minus a -4 over x2 minus x1. 0 minus a -3. And what happens with a minus a negative? Plus a positive. -1 plus 4 is 3. 0 plus 3 is 3. And 3 divided by 3 is, so the slope of this line is a positive 1. Any questions about 9 through 11? Number 12, they asked me to graph it and identify the slope and the y-intercept. Well, before I graph it, I'm going to identify the slope. What's the slope? -4/3. What's the y-intercept? 2. Remember that when you're looking at it in this form, the y-intercept is where I start on the graph. So I'm going to start 2 units up on the y-axis. The slope in general should be sloping downward. But this is how much the y value is going to change compared to how much the x value is going to change, right? So it says from here, I'm going to go down 4 units. 1, 2, 3, 4. But I'm going to go over to the right 3 units. 1, 2, 3. I'm going to plot that point. And I can continue that pattern down 4 and over 3. Once I had 2 points plotted, I could connect my dots. Notice the slope of my line definitely forcing me in a negative direction, and the y-intercept is definitely a positive y-intercept, so I can see that in general it gives me a good idea what my graph should look like. Angelique. Okay. A lot of people get confused with this because it says a negative out in front of that. But understand that you could write that this way, -4/3. You could write it this way, 4/-3. Or you could write it the way they had it written. These are all the same. This tells me that I'm going down 4 because it's negative. This tells me I'm going to the right 3 because it's positive. Down 4/3. Or I could have looked at it the other way. I can go up 4. 1, 2, 3, 4. But if I go up 4, which way I'm going to have to go? Left 3. 1, 2, 3. And I can see that that point's on the line. Okay? What I can't do, and so many people want to do, is this. When they see a negative out in front, they think that that means the numerator and the denominator are both negative. But if I did that, it says I'd go down 4, and it says I'd go to the left 3. The slope of my line would be what type of slope then? A positive slope, which is why I encourage people, look to see, is your slope negative or positive? Gives you an idea if your graph is going the right direction or not. Look to see where that y-intercept should be. Is that y-intercept supposed to be above the x-axis or below the x-axis? Because again, even if the slope wasn't 100% correct, this, in a general standpoint of view, would give me an idea of what's happening to the information that I started with. Although I started out here, am I having a positive effect or a negative effect on that result? A negative effect. It should be going downhill. Okay? There are things that I want to have a negative effect to. My expenses. It'd be nice if my expenses keep doing what? Going down. There are things that I don't want to have a negative effect to. My salary. I'd like that my salary goes what? Up. Everybody good with 12? Number 13 is another one that I say is difficult because there's so many possibilities. Because who picks X? You pick it. And you literally could pick anything. But I'm going to tell you from a graphing standpoint of view, some numbers graph easier than others. This was 2x minus 5y equals 10. And although I can use this form of the equation, it's hard to work with. Although I can pick any value for x. Let's say I picked 0. If I put 0 in for x, I'd have 2 times 0 minus 5y equals 10. This one's going to work out okay, because what's going to happen to this? It's going to go away. And what would I end up dividing by? Negative 5. And y would be a negative 2. That one's easy, right? But what did everybody pick for the next value of x? And if I pick 1, and I can, there's nothing wrong with it. I can pick 1 for x. If I do that, 2 times 1 is, I'd subtract 2 from both sides. I'd have a negative 5y equals 8. And then I'd divide both sides by negative 5. So y would be equal to a negative 8/5 or a negative 1.6. Is that going to be easy to graph, or am I going to have to kind of guess at where it's at? Guess. So, now I want to talk about another way that I could have looked at this. It would be better for us if this was not written in this form. What form would it be better if it was written as? It would be better for us if it was written in this form. Which means I have to solve it for y, and I'd start by subtracting 2x. Negative 5y equals negative 2x plus 10. Everybody okay that far? What do I do to get y by itself? Divide by a negative 5. And if I divide one thing by a negative 5, I've got to divide everything by what? Negative 5. These are going to cancel out, leaving me y. A negative divided by a negative is going to make a positive. And a positive divided by a negative is going to make a negative. Why would I tell you that this is going to be easier to work with? Yeah, but I'm filling in a table. And I remember, I get to pick any value for x. I can really pick anything. In fact, we said if we picked 0, we'd get a negative 2. We said if we picked 1, I'd get a negative 1 point, or 1.6, whatever it was. But I don't like that number. It would be nice if all I had to work with was integers. What values could I pick for x so that I get integers for answers? I could pick 5. I like 5. 5 works for me. Because if I put 5 in here, what's going to happen to these 5s? What's 2 minus 2? What's another number that I could pick? I could pick 10. If I put 10 in here, 5 goes into 10 twice. 2 times 2 is? 4 minus 2 is? I could have also picked a although the 5s would cancel out, this would be a positive times a negative, so it would be a negative 2 minus 2 more, which would be a negative 4. Tell me, would this be easier to graph than this? Does everybody see why it might be better if it was written in this format? And it makes choosing your values of x easier because if you see this fraction, all you've got to make sure that you're doing is picking a number that's a multiple of the denominator. It's going to make the fraction go away. Pretty good? Number 14 has 2 questions. Which lines show linear relationships? To be linear, they have to be a straight line. The only one that's not a straight line is A. So this should be B, C, and D. In order to be proportional, it not only has to be linear, but it also has to go through the origin, and the only one that goes through the origin is B. For number 15, we're talking about 2 different equations. I have Steve, I have Chelsea. And if I can write the equations in this form, then they'll be easier to look at them together. Remember that B is how much they're starting out with, and M is how much it's going to change. It's a rate of change. Steve started with what? That's B. $25 per week. That shows me that it's a slope because it's per week. It's a rate of change. And if he's spending it, is it a positive or a negative rate of change? So it's a negative 25x, the slope. Everybody with me for Steve? What did I start at with Chelsea? 30. And how much is it changing? A positive 30x. Okay? Everybody okay with the 2 equations? I had Steve. I had Chelsea. And given the graph that they gave me, I say one of these 2 would graph easier. Would you pick Steve or Chelsea, given this particular graph to graph things on, and why? Can you tell me why? Okay. I agree, it's going by what? 50s. By the way, I always look at where I'm going to start. Where's 30? Am I going to have to guess at where 30 is a little bit? That makes this a better one to graph. It's going to be easy to recognize whether I've got it in the right spot or not. If I start at 250, that's here. If I'm taking 25 off per week, well, 25 doesn't work real well because I have to guess. But in 2 weeks, how much is he going to lose? So at the end of 2 weeks, I could go down to 200. And then I can keep every 2 weeks going down by 50. And what can you tell me at the end of the 10 weeks? Steve is broke. He probably is a teacher.
Oh, you broke? Wow.
If it's the end of the month, I'm always broke. Hmm? No. I get paid, but... Hmm? Again? Oh, you could, but is that dot necessarily real accurate? No. And I would go down by 25. By the way, it also made this one hard to graph because if I had to go down by 30, each one, or up by 30, each one of those would kind of be another guess, wouldn't it? It's not that I couldn't graph it, but it wouldn't be as accurate as graphing Steve's. But you understand why one would be more accurate than the other. Number 17. And again, I know that you could put this in a calculator, but I want to talk about the other way to do it. Because we talked about estimating this before. This one everybody should kind of know. 3 goes into 19 how many times? 6. And there'd be 1 left over. So this is 6.3, actually 6.3 repeating if you divided it out. Well, everybody should know what pi is, approximately. Okay. So I'm going to put 3.14. 3.1 certainly would have been close enough in this instance. This is the one we got to remember how to do. And remember, you want to find a number on each side that you can actually take the square root of. The square root of 4 is, the square root of 9 is 3. Which is it closer to? Is it closer to 4 or is 5 closer to 9? It's closer to 4, and it's quite a bit closer to 4, isn't it? So this is 2.1. It might be 2.2, but it's not 2.5, 2.6, 2.7, is it? So let's say I took the higher one of those, 2.2. 2.2 and 3.14, if I put them together, would only be 5.34. Which is bigger? Is obviously bigger, so the 19/3 is larger. Everybody good? Questions? What should we do tonight? Study. Okay.